I'm going to be showing you a little bit about building backend services in Swift. There's going to be a few introductory slides, and then I'm going to jump in and build a to-do list API right here. I'm Daniel. I do iOS development at Ride, and you can follow me on Twitter at DanTommel. What are the key parts of building any web service? So most web applications take at least two key parts, a HTTP server and a router. The Nest protocol provides a set of protocols for allowing different versions of these components to work together. It's similar to Ruby's unicorn and Python's unicorn. This is important as it means you can do things like develop locally with a simple debugging server that allows you to do a bunch of fancy LLDB stuff, but then deploy to production with something way more efficient. Or to do something that supports different protocols without really affecting any of the code in your code base. So the HTTP server that I'm going to be using in this example is called Curacao. And what a HTTP server does is it opens a socket for reading, and then when someone does a web request, it writes to that port, it reads out the headers and the various parts of the request, and hands it to the router. The router, in our case, is Frank, and we hand it a set of patterns to match and code to execute when a request matches that component. Then we pass a response, that gets sent back to us, and then we get to use the lovely API in our apps. Here's a quick hello world example with Frank. We have a simple function that takes a name and then returns some HTML to return back to the user. Ideally, this would be in a separate file, but fitting it all on a slide, it works. So when you get, we return a response with the name hello world. And then if you get hello name, then it returns that name. But now, I promised the brief would be short. You can ask questions at the end. We're going to level up, and we're going to build an actual API. So now, time for some of this. And let's hope this works. OK, cool. That bit worked at least. So what we're going to do is cool. So I already created a directory called live. It's currently empty. What we're going to do is we're going to create a package.swift. Package.swift. A sources directory, and we're going to create a main.swift inside there. Main.swift. Cool. So I'm going to open up the package.swift. And how many of you have used Swift Package Manager before, looked at it, played with it, know anything about it? OK, so a few of you. I'm not going to go in detail about how that works right now, because that's a talk in its own. But what we do when we're creating package.swift is we import package description. Then we create a new package. Name, live. And then we have a few dependencies. Dependencies. Cool. We're going to have Frank. GitHub.com/. I'm recording my screen, which has made this screen go really dim. So if I'm straining at this monitor, that's why. Major version 0. And a package of mine called resource, which automatically handles serializing our models to JSON, or whatever other content encoding we're using, because it handles doing content negotiation for us as well. resource.get major version 0. And if I had internet, running Swift build would now go away and fetch all of those dependencies and then set them up locally and compile them so we can use them inside our code. But because I don't, and I was organized, I'm going to copy them in from another folder, /demo packages, /. Cool. And I'm also going to copy a helpers file from that project that you'll see a little bit of later, but it's stuff that you don't really need to know about right now. It's just little helpers to make the code a bit cleaner on the slides. And it's in the repository that's on GitHub that I link to at the end. Demo sources.
Too many dots.
Helpers, sources. Okay. Cool. So now what we're going to do is make sure this builds. Just by running Swift build. Oh, damn it. But the things are there. Oh, wait, do I need to... This might be case sensitive, that's why. I'm hoping that's all. What even is software? Okay. Apparently Swift Package Manager is case sensitive. Today I learned. There's some build warnings, but we can deal with those later. That's because different Swift versions and things changing. It's fine. Everything's fine. I'm just now imagining the GIF with the dog, the room on fire, just going, this is fine. So now we're going to open up the main.swift and actually get into building something. So what I'm going to do is first import all the dependencies that we touched the types of for now. This is just to avoid anything exploding later on if I miss something. Frank. So we're using Frank for the rooting. And then we're using Nest and Inquiline to handle the types between the different frameworks. So Nest is the specification, and Inquiline is the implementation of those that Frank uses. We have a library for doing JSON, and we have resource, which I think is everything. We may find out later that something won't build, I know because I missed something, but it's fine. So what we're going to do is first we're going to create some simple data types. So we want a enum for the status, which is going to be a string enum to return with the API. And we're going to have two cases, one for outstanding tasks and ones that are completed. We're then going to have a to-do struct, and that is going to inherit from the resource protocol. And from that, we're provided with default implementations of a bunch of methods for the deserialization of it. And it's going to have an identifier that is a string. It's going to have a title, which is also a string. And then it's going to have a status, which is a status. On init, we're going to create a UUID. Oh, yeah, I need to import foundation. For this to then build on Linux, you'd have to wrap foundation in an if Linux import Swift foundation, else import foundation. But because this demo is only running on my Mac, I'm not going to do that. Title is a string. And a status is a status. And that's going to default to outstanding. Then I'm just going to hook these up. And that's going to be that. These are actually going to have to be vars because I need to update them later on. And that's easier for now. OK. And then we're going to do it.
You forgot to assign the identifier.
Oh, yes.
But there's a typo in the parameter name.
What is there a typo in?
And the parameter name, identifier.
Considering the fact of a lot of what I do is typing, you'd think I'd actually be able to type. And then we're going to implement the attributes function that returns a dictionary of string to any for when we return for deserialization, because we use an enum, and I can't automatically infer that it's an enum that converts to a string. So like resource will just ignore it, and it won't end up in the JSON. So we're going to return identifier, title, status, dot row value. OK. And then for now, we're going to have an array of to-dos in memory, because otherwise I need to set up a database, and I don't trust database setups on stage. To-do, then it's going to have an identifier of 1, 2, 3, 4, just for the demo later on, a title of write talk for swift.berlin, and a status of dot completed, and create that there, and then a to-do with the title of present talk at swift.berlin. And that's going to be outstanding. So now we get to do the fun bit and get those to-dos. So for that, we do a get with the path name of to-dos. We ignore the request we're getting, and we return a collection response of to-dos. Cool. What this will do, so collection response is defined in the helpers, and it just uses resource to convert it into JSON and then returns that back to the client, which we can see here. So if I now, oh god, that's not what I wanted to happen. OK, cd talk, Swift Rest demo, live. If I now Swift build, what?
String is uppercase.
Ah. OK, so now if we run that, the server starts, and then I come over here and hit that, and we get the to-dos we just defined in the array returned back to us in the client. Also, I'm surprised that mostly worked first time. So I'm going to shut down the server, and So it'd be pretty useful to be able to create to-dos, right? Like I figured, like unfortunately, to-do lists do keep getting longer, which sucks, to be fair. So if we post to to-dos, we're going to get a request that I need to call that for now because reasons. And then we need a variable reference to that because we need to read in the rest of the body. So what we're going to do is we're going to read the body. And for now, we're going to ignore errors. And just like implicitly unwrap all the things. Pass equal. We're going to pass the JSON out of the body. And we're going to get the dictionary value. Then we're going to get the title. Oh.
The parse.
Yep. It's not doing the clicking thing. Okay, and then we're going to let the status go past status string value. Then we're going to create a new to-do. The status. And we're going to append it to the to-dos. And then we're going to return the new to-do.
Shouldn't it be a put request?
It would be a put if we were putting to to-dos /identifier. But because we're letting the server handle that, it's a post. So then what we're going to do is hope this builds. Oh, that's why. That is optional. The one downside of writing a lot of code in Vim is that you don't know when you're actually like pulling something out of an optional. Okay. So then if we go to post to-dos, we get the new to-do here because we created one with hello Swift Berlin. And the status of outstanding. And then if we go and get to-dos, there's our new to-do. Pretty simple, right? Another thing that people often want to do is, oh no, I don't want to Vim here. I want to Vim over here. Is get to-dos with an identifier. So for that, we're going to define a function to do with identifier. Identifier string. That's going to return a to-do. An optional to-do. And then we're going to get that from to-dos. Dot first. And we're going to have a function of get to-dos with an asterisk to represent a variable that we're pulling out. Because one of the cool things about Frank is it'll actually do type-safe URL parsing. So now if I define here that we get the request and an identifier that is a string, we will get the string identifier. But if, for example, I only wanted to pass integer identifiers, I could specify the identifier type as an int, and unless we could like pull it into an int, it wouldn't match that request. But everything will obviously match a string because that's what URLs So what we're going to do is we're going to guard let to do with let to do equal to do with identifier with the identifier. Else we are going to return a response of dot not found with a content type application JSON. No other headers and content of an empty object. And then, otherwise, we're going to return the to-do. Then we're going to go over here. Oh, wait, no. Build. This is not Ruby, and I've been writing Ruby today. So then, if we go over here, we have the identifier 1, 2, 3, 4 for this talk. So if we go ahead and get that, there we go. So, I want to come over here and here's where we pretend that everything worked. If you want any of the code, oh, that didn't actually happen. Here's where we pretend everything worked. And any questions?
Why did we again?
Why did we again assign this request in the block to a local variable again?
Pardon?
Can you open
Yeah.
the source code?
Where is the thing? There is the thing.
So I think you have to scroll up. Or no. Yeah, and line 3, 4 exactly.
This one?
Yeah.
So because reading in the rest of the body is actually a destructive action,
Okay.
it's a mutating func on the struct.
Mhm.
So the way that Cursor works is it does everything as lazily as possible. So it doesn't actually read the rest of the body struct until you ask it to.
Mhm.
Just in case you have, like, I don't know, maybe you're uploading a video and you're doing like large packets at a time. You don't necessarily want to read that all into memory and then copy it around. You might just want to kind of like lazily do that and then stream it in somewhere.
All right.
Cool. Anyone else?
Databases. So what would you recommend?
So there's no one true database for any given thing. So you're generally okay with Postgres. And then if you have specific problems, use a database that solves those specific problems.
Right, but is there something that has reasonable Swift bindings?
So there's a bunch of like lightweight SQL wrappers and things for Swift. There's one by an organization called Zero. GitHub.com/Zero. They have a bunch of libraries for doing various different things. And I know they have at least one SQL wrapper. There's no like good ORM yet. So there's no like core data or realm type thing for like doing those kind of bindings. I've been working on one, but it's not ready yet. And like because Swift on Linux is so new, which is the only time we could reasonably start like actually doing web development with it, there's nothing out there right now that's properly battle tested.
Okay.
Does that answer your question?
Yeah.
Cool.
So, do you use Swift as a server in? Do you deploy it? Do you work it in production?
I have a few things myself running on Heroku and AWS, but they're just like mostly like little things for like side projects right now.
Okay. And
It's reasonably easy to deploy to Heroku. There's a build pack for it. In fact, there's a few. Just search on GitHub for a Swift Heroku build pack, and there's like 5 of them. If you look at any like Travis CI script for a Swift open source project, there'll probably be something in there that'll be like a one-liner to get Swift installed on a system as well. If you want to automate that with like Chef or Puppet or whatever you use.
okay, thanks. Nice.
Also, I think IBM Bluemix has support for it out of the box now.
Okay.
Cool. Anyone else? I guess we're done.